Right, so as promised, here's my tutorial for doing the K4 method on a 4x4 cube. This isn't the exact method which is explained in Tom's tutorial. That's just basically because K4 is an open source method, which basically means you can do whatever you want as long as it's in the rough order that the method says. So to start off, you do two opposite centres. I do white and yellow just because I like yellow as my last layer, but you can do whatever you want. Become colour neutral. Just see what works for you. Preferably when I'm solving a real cube, I'll do the yellow side first and then do the white side second, just because it leaves me for the next step better. In this case though, I've got already got two whites solved, so I'll just stick with the white side. So now I've done the white centres, I'll now go on to doing the yellow ones. Right, so now that's done, you next want to proceed and build a 1x3x4 block, which is basically one complete face bar one side. Now there's many ways to do this, where you can pair up edges or you can directly solve. I personally go for the direct solving because it's slightly faster than trying to pair up edges. So to go about this, I usually try and find at least one corner to put into place first, and I also use the same colour block each time, which is the white, red, blue, green block. So here I've got the white, red, blue corner and also a white, red edge. So I'll connect that to the white side and then I'll start inserting the other edges around that. So I notice here I've got a white, blue one, so I'll slot that one in. Now while I was doing this, I saw other pieces and saw this white, red one, which is an easy insert, and here is a white, green, so I can actually put that one in easier. Now while I'm doing this, I also try to find the other white corner, which luckily is here, and just insert that whenever. So I'll just finish off this 1x3x4 block, and I'll go on to the next step. So this is that's the 1x3x4 block you can see there. So next we just go around solving the rest of the centres, but as you can see we're limited to the turns U, the right side and the left inner slice. It's after a while it just comes second nature to use them, so it shouldn't be a worry. So here I'll just start doing the I'll do the red ones. Again, you can do these centres however you want. I just find doing bits adjacent ones easier, just because it's preference. Now if you want, you can do opposite ones or whatever other method you might find. Just see what works for you. So now we've finished this block. Now you have to finish off the white layer. Now Tom, in the way he does it, he tries and pairs up the edge, pairs up the final edge, and also puts a corner with it. But I do it slightly differently, whereas I just pair up the orange white edge, solve that edge, and now when I slot in the two corners, I also try to drag in a edge piece with it. So it's basic F2L algorithms if you use Friedrich. So now we've got our first layer done. The next step is to try and start solving the first three layers. Sometimes if I've spotted a few pieces, I'll actually do a sort of a keyhole method here, which is setting up the pieces. Let me do it under that. This red green piece here, I know if I just turn the D in a slice, it'll match it up with its corner. So if I take that out, undo the D slice and then put that piece back in, put that pair back in, that'll be solved. I don't always do that, it's just sometimes helpful if you see a lot of pieces, and it's generally faster than the algorithms you use to insert the F3L algorithms pieces. So again here, the orange blue one, I can do exactly the same here, and that's unsolved. So when I'm doing F3L, I always have orange on the front, just for easier colour recognition. I can usually do this step without any sort of pauses or anything like that, just all fluid motion. So here, there's the blue red one that you can slot in. I think that one is, yeah, red green. So now we've got to the last layer. There's a lot of things you can start doing here. I know Tom uses CMLL, but that's just because he's a RU user. I haven't learned any of the CLL variations, but I'm going to learn COLL sometime. But the way I do it, I just use OLL PLL, which is actually quite useful if you're using K4 on a 5x5, because you can also solve the middle edges while you're doing it. So I'll just do OLL here, just simple sooner, and also the J-perm just to permute my corners. So now we've got the corner soles. The last thing we have to do is doing the edges. Now there's a lot of things you can do here. You can learn a lot of algorithms or just use commutators all the time. Personally, I try to use as many algorithms as I can because they're a lot faster and they're usually more useful, whereas commutators, they're a bit slower, but you can use them on trickier situations which an algorithm would be harder to find. So here I usually just look at pieces and see which ones I like solving first. So here I can see this blue edge, this yellow blue edge, and this yellow orange edge, which I know when I if I use a commutator on these, it'll solve all the blue pieces. So there's the blue ones. Now the next thing I want to do is solve an adjacent edge, just because the parity fixes, if I get one, are a lot easier if the pieces are adjacent. So here I saw that this yellow orange needs to be permuted here, which means that if I move that one into there, it's going to solve all the orange pieces as well. Again, this is another simple commutator, but this is actually a lot harder to do on a real cube and a lot slower, so I try to avoid that one. Now here I know I'm going to get a parity, so I'm just going to try to solve one edge in each of the bigger edge groups. So I'll solve this one, and I'll also solve that one. So after a while these commutators just become second nature to you, and you know to use them and make them up on the fly. So here we go, we've got our parity. The parity fixers explained on the tutorial. It's very simple. It's a lot faster than the one you'll know for reduction. That's if you use reduction. And it just makes things a lot easier to solve the parity. So that's basically what K4 is. I'll try and break up the steps in other videos and show you exactly what's happening in each one, but that's just a quick overview of what you do.